Hi everyone, welcome back. In this video, we're going to take a look at exponential relationships and how we can write equations in sketch graphs for exponential growth and decay. So to start off, we're going to be looking at the equation for exponential relationships. So y equals a times b to the x is the form that we'll see all exponential relationships the form in which we'll see all exponential relationships. And it's called exponential because one way to think about it is we have x in the exponent. So exponential relationships are defined by repeated multiplication. So with linear relationships, we're repeatedly adding the same number again and again, which we call the slope. So for example, we might be adding 3 each time to get from one y value to the next. For exponential relationships, instead of adding a certain value, we're going to be multiplying by a value. For example, if we're doubling something, we're multiplying by 2. If we look at our equation, y equals a times b to the x, a is what we call the initial value. So the y value when x equals 0. And then b is the common ratio. In other words, what we multiply by to get from one y value to the next y value. So for example, if we had a table, x and y, we start at 0, 3, 1, 6, 2, 12. So here you can see that our initial value is going to be 3, our y value when x is 0. And then the common ratio is what we multiply by to get from one number to the next. So here we can see that we're multiplying by 2. So an equation here would be y equals 3 times 2 to the x power. Okay, one quick note is exponential relationships. There's two types of exponential relationships. There's exponential growth. These types, you'll see a curve like this, so a curve that's going up. And this happens when b, and specifically, when b is greater than 1, because we multiply by something greater than itself. So each y value, if we multiply by 1, our y value doesn't change, it's just itself again. If we multiply by something greater than 1, we're multiplying by something greater than itself, so it's going to grow and grow and grow, and so on. We also have exponential decay, which will look like this, so it's kind of flipped. We're going to have a curve that's going down, and that happens when b is less than 1. And b is also always just going to be greater than 0. We'll just be looking at positive values. So here what's happening is we're multiplying by something that is less than 1 or less than itself. So if we take a number like 100 and multiply it by 0.5, that's less than 1, so we end up with 50. We end up with our next y value being smaller, so that's why we call it exponential decay. Okay, let's take a look at a practice problem. So here we start with 81 Oreo cookies on day 0. Each, let's say each day, you eat 2/3 of your cookies. In other words, you have 1/3 left of your cookies at the end of the day. First, we're being asked to write an equation. To write an equation, we know it's going to have this form, y equals a times b to the x. We just need to identify what a and b are. So a and b are specific numbers related to the situation that we're given. A is our initial value when x is 0. Our day number is 0. We have 81 Oreo cookies. Sometimes it also helps to make a table here. So x is the day number, y is the number of cookies. When x is 0, y is 81. So a is equal to 81. And then b is what we multiply by to end up with our next y value. So let's take a look at our table. After day 1, we have 1/3 of our cookies left. So we're taking 81 and we're multiplying it by 1/3. So one note is the 2/3 is just saying how many we're taking away. The common ratio is actually going to be 1/3 in this case. So b is equal to 1/3. So 81 times 1/3, or divided by 3, gives us 27. So we found our a value, we found our b value, and our equation then would be y equals 81 times 1/3 raised to the x power. So we just plug in our initial value, plug in our common ratio, and then we're done with our equation. We're also being asked to graph. For the graph, I'm going to keep filling out my table to help plot the points on the graph. So after day 2, we multiply 27 by 1/3, or take 27 divided by 3 to get 9. Day 3, we multiply by 1/3 to get 3. Day 4, we multiply by 1/3 to get 1. Finally, day 5, we have 1/3 of a cookie left. So maybe we eat one of the cookie parts in the cream, and then we leave the other cookie part. So we've eaten 2/3, we have 1/3 left over. If we want to graph this for letter B, so 0, 81 is one of our points. Another point is 127, so right about right here. Another point is going to be 2, 9, so about right here. 4, 1. Sorry, 3, 3. I skipped that one. 3, 3. 4, 1. 5, 1/3. So as you can see, we end up with a curve. It's a pretty steep curve, and then it kind of levels off at the bottom here. So we have an exponential curve, and notice that this is exponential decay. And that's because our common ratio is less than 1. So our y values are getting smaller and smaller, so we have a curve, that's going down, like that. Okay, so we graphed our situation. Finally, we're being asked how many cookies do we have left after 5 days. One way to find this is to just look at our table if we filled it out that far, so we can see that we have 1/3 of a cookie. Another way to find this is to plug in x, for x, plug in 5 into our equation. Y equals 81 times 1/3 to the 5th. So we could take 1/3 in parentheses, raise it to the 5th power, and then multiply that by 81. If we do those calculations, then we end up with 1/3 of a cookie left over. Sorry, and I just noticed that I was blocking part of what I wrote out, just this very last part where I graphed the last few points. I think everything else is clear though. Yeah, okay. So here we went through an example of looking at an exponential equation, writing an exponential situation, writing an equation for it, graphing it, and answering a question. We also really quickly went through what exponential relationships was and the difference between exponential growth and decay.